Get it going. Okay, so sitting under science, week 11, which means that we only have about 9 weeks left of school. 1 week is gone, basically, because next week is spring break. So some of y'all are going to be relaxing, you know, drinking some Coca-Cola by the pool, just kind of getting a tan, make sure you put a sunblock on. And then some of you guys will be working very hard because y'all need to catch up your grades. Some of y'all need to catch up your grades. Anyone else? Yeah.
Perfect.
Yeah, you're perfect. Everyone here is the same for you, apparently. Everyone else.
Yeah, I have
all right. So next week you guys can. It's different than a regular school. Okay, regular school. Even if you were failing, you really wanted to do work. You really couldn't. Like you can do your work at home, but like there's no one around. You here in this school, you can work. So all of them, go in there and do labs if you're missing a lab. Do some notes. Get your science notebook set up. Your science notebook will be due in about 7 weeks. Okay, if your science notebook looks like not very good, then you need to work on it. And next week you have an ability. You have to unlock of the unit itself, so you can go back in and take notes if you need to. Make sure you do that, because if you don't do that, that's on you. Not on me, it's on you.
There's notes in the Learning Center.
If there's notes in the Learning Center, you can use that. But I do recommend your own notes.
Yes.
Because you guys need to get done. You should have a note for every single lesson that you were here. Some people came in later. Obviously, you need to get that done. I also left all the units open, so if you did come in later, so if you say you started the semester a month or two into the semester or whatever you did, you also need to make sure that you go back and read some of those units and those lessons, because the semester test is cumulative. No way around it. I can't get in there and do anything, but I can't make you only have this certain test. I can't. There's no way to do that. So that's what we need. I don't care. You know I don't care. You can open it. He opened up a drink and he thought it was weird because it's like a class. I'm not like that. I don't really care.
I was bringing that to Dr. Pepper machine.
Yeah, me too. Angry. I'm angry. Yeah, there's
At our site right now, there's
a Dr. Pepper machine, but it doesn't give you Dr. Pepper. It's just actually all water. So false advertising.
Exactly.
I agree.
I don't like Dr. Pepper.
All right, so again, recap. School's ending soon. Y'all need to get grades up. Progress reports went out the other yesterday or the day before yesterday. So if you whatever your grade was yesterday at I don't know 11 a.m., that's your grade. For the quarter, not on your transcript. Okay, not on your transcript. Okay, some people only have F's right now, and by the time it gets around, they get out an A. I don't know. But right now, when you get that letter in the middle, and it shows you have an F in something, and you're like, but I brought it up, Mr. Raymond! You probably did. Because right after I did it, I checked, and it was like 7 tests done, which probably brought your grade up after. But I have to have a cutoff, and that was my cutoff. So don't worry about that. Progress grade. I'm happy. Move past it. You know your grade. All you have to do is log in. Click on the grade book. That's it. All you have to do. All right, come with me. Make sure your science notebook again is getting put together. There's 100 points. Some people last semester turn in theirs, and it looks like my 2-year-old scribbled. There he is. There he is. There you go. And there. No, they look like he scribbled on some paper, and not him, but like my 2-year-old. Seriously, scribbled on paper and turned it in. And then sat on it and spit on it too, and then had food on it. It was horrible. Okay, seriously. Some people turned it in, and I got 115%. 115% because I give extra credit. Remember, if you do cool drawings in the front, that's science related. If you do pictures on your notes themselves that are science related, or I tell you to cut and paste out from the internet and glue it on there, that'll get you extra credit. So there is a chance to get 115%, the extra credit.
You can just use stickers.
If you have science stickers that match it, then you're more than welcome to use stickers. Whatever you want, I don't care. As long as it's together, that you have a table of contents, you have your graph of all your quiz scores and your test scores, you have a notes basically for every lesson. You have to have either the vocab in the back of the area or the vocab has to be embedded in your notes on the bottom or something. It has to be somewhere. If I look at your notes and it's just a bunch of writing where there doesn't look like there's any vocab, I'm knocking that all off. I'm going to grade it harder this time. So it could be the difference in a D and an F for some people. So, and I don't want you to cry to me when I give you an F. And you're like, well, Mr. Anita, I know what to do. You had 90 days to do it. It's on you. I graduated high school. It's on you guys to do that. Yes.
With the journal, we're supposed to keep every single set of notes that we make.
I would recommend that, yes. Turn them into work
example.
samples. Which I said don't do that.
I don't think those really said that, because I can.
Okay. See if you can either go get them and make copies of them. Because it's only what? It's only 10 copies you have to really make for my class. Or if it's not really very specific a bunch and you have a bunch of extra notes for that same section, you can just keep those. But remember, I went over that on each of the notes. I want your name. I want the unit name. I want all the stuff on there. Okay, I want your goals, the goals for the lesson. I want all that on there. If that's on there, you need to mark down for it. All right, let's actually get into some science now. All right, so we're now not talking about the Earth anymore, like we are, but not like specifically on the Earth. We're kind of jumping outside here. We're going to talk about the Earth itself as a whole. We're going to talk about the little floaty ball that flies around us. The little floaty ball of the sun, yeah. No, we're going to talk about the moon, and we're talking about that big old thing in the sky that allows us to have life on the planet. We're going to talk about that relationship. A couple of things we're going to talk about today are the phases of the moon. And hopefully I'll give you an analogy that will help you remember all the phases of the moon. I know that. I just want to help. Then you're going to know what a solar eclipse is, what a lunar eclipse are. We're going to be talking about all the various shadows and things like that. We're going to be talking about, what are we talking about? What's it talking about? Lunar eclipse, solar eclipse.
Revolution.
Revolution. Thank you for people in here last hour helping me out. So appreciate it. Oh, sorry. You're doing it. All right. So here are the essential questions for the people in the class that we're going to talk about, as well as the people on the internet. What are the differences between a solar and a lunar eclipse? An answer that is not okay is a solar eclipse has to do with the sun, and a lunar eclipse has to do with the moon.
I can try to fold.
You can try to fold it and boom, you're off. Other people cannot. Other people, you look at them and I say lunar eclipse and they go, they stare at me, their eyes start to cross, and then they drool out of the right side of their mouth. And they don't have any idea what I said.
I drool out of the left side.
Left side of the mouth, drooler now. Left side. He switched it. He ran out of drool on the right, so he had to switch to the left.
You see my question, that's where we're there now.
Yeah, you want to do that, okay? So make sure you know the difference, and you should be able to know the difference after today, because we're specifically going to go over that. Next. If you didn't write it down, write it faster. Let's see here. There is give me 2 seconds. I'm actually going to put it in the thing. We're going to watch this at the end, but I'm going to go ahead and put it in the 2 seconds, guys, on the internet. I'm going to put it into the box so you guys can see it. Later on in the class, remind me, I'm going to go ahead and put that YouTube video. Quiet, guys. I'm going to put that YouTube video into the conversation box so you can click on it and go watch it after this. Okay? So let's keep going. Okay. So the Earth-Moon relationship next. Okay. We need to know the difference between what a rotation is versus a revolution. A revolution is a bunch of people who do not like their monarchy or their tyranny, and they rise up against the government. I'm just kidding. That's not the revolution. That was about the history class. It's just a revolution. You're like, okay. This right here is a what? Revolution or a rotation? Rotation. Live. It's spinning around. You have to stay in axis. Okay, no, but very specifically, it is an axis that will be running. So you get it's finished. So there you go. This is a rotation. Now, if we have, say, a sun in the center, you're now my sun. You're the light of my life. Okay? There you go. We're all kids. I'm my homework kid. He's a science kid. My science kid is my kid. So if I start going like this, and I start walking around, okay, and as I go all the way around, once I get to the other side of her, which I can't go over the desk, I'm not that flexible anymore, I will probably break something. That is a revolution. that is one time around another body. Okay? The revolution, just so you know, for it to do this, 24 hours for the sun, for the Earth. We know that. There's 24 hours in a day. Kind of makes sense. But if I go like this, it takes 24 hours to go from point A, spin around, and go to the exact same point. That's straightforward for Earth. We know this.
Yeah.
Now, a revolution, some people think it's 365 days. It is not. The essential question was on a slide back. You can rewatch it later. All right, so the Earth revolves around the sun once every 364.25 days. Not quite 365.
It's technical.
It is, because that's why we have a leap year a leap day every single 4 years. We have 1 day every 4 years. Which means if you do the math, every 4 years we add a 4 there, it's an extra day. And we basically are catching up.
It's next year.
Is it next year?
Yeah.
Good for me.
Every 4 years.
An extra day with you guys next year. That's awesome.
What's your plan on your day?
Oh, my God.
Okay. So I'm gonna be around.
Actually,
All right, so make sure you pay attention. Rotation is around an axis, revolution is around another body next. Okay, couple things. The solar energy matters on this planet because we have various, like summer, fall, winter, spring, all that stuff have to do with the solar energy as well as the tilt of the Earth. This is the solar energy part. As energy hits directly onto the planet, it's dead on. It's typically hotter or warmer than the area that is not. That's why it's the North Pole, the South Pole are cold. It's one of the reasons why they are. It does not get direct sunlight. It's like an angled sunlight. Now, the equator right there has direct sunlight. Yes, sir.
your Earth is not tilted. Your Earth is.
Oh, no, not yet. This is just showing you general. The Earth is not tilted. There is a real tilt to the Earth, it just doesn't show it on here. Next. No, next. That's just showing you the math unless you guys want to do the cosine and stuff.
Cool.
Yeah. I got it. All right, so why does the length of the day change? The tilt of the axis, by the way, this is how the Earth actually looks, if you straight up and down. It is not perfectly like this, spinning like this. It literally spins on the axis. Some people believe it's when the moon hit us is what put us on our axis.
How do we know that it's in that angle?
How do we know? Because we've been out in space and looked at the Earth.
I know that there's a how that line around it to know that it's tilted.
Yeah.
No, it doesn't.
Yeah.
So that's the space needle.
I'm gonna say it.
Literally, no, in space, there's this like metal contraption that actually holds the Earth.
I'm talking about the equator line.
Oh, the equator line? No, the equator is just the center. There's no real line.
How do you know that's the equator? Like, how do you know the equator is not?
Because they mathematically figured it out a few hundreds of years ago, and I didn't have to deal with that to look it up again. The guy with the beard, there was a really old guy with a beard that probably did it. That probably was in a monastery somewhere that probably had nothing else to do other than like measure the Earth. And so I totally give it up to him.
Okay.
No, they calculated it down. Basically, they looked at this, they broke it down into grids, and it's just the middle grid. It's the middle line on the grid. It's all
Okay.
yeah, it's just the middle. And then there's another one that's like a line.
My axis and axis.
Yeah, I'm glad you get to all the axes. There's
Yeah.
no Z one.
Well, there is.
Time.
There is.
There is that extra one that doesn't exist. Yeah. All right, so the tilt of the axis, the rotation, and the revolution, all of those play on how long the nights and the days are. We change our times to kind of help with that. That's why we did savings time and all that stuff. But in general, I mean, no one likes it when it gets dark at like 5 o'clock.
I didn't.
I hate it.
You like it?
Yeah.
I like it. I like it until like 8 o'clock, like usual, because I like to sit outside when it's light and you hang out with my kids. I like it when it gets, when 8 o'clock, I go outside and so light and I can hang out with my kids and put on the sleeve and wear my Black Widows and I'm for some reason I have a lot of Black Widows in it. More than usual, so I'm just trying to spray. All right, next. Okay, this is not a rotation. Obviously, the next one will be a true rotation. But the equator is directly straight on, 90 degrees. Tropic Cancer is to the north, Tropic Capricorn to the south, and then the Arctic. Definitely direct sunlight is warmer. Warm. Next. Now you're going to start seeing some rotation. Does anyone know what season this is? There you go. What season is that for us? So we have a season change, obviously, right? It's going to be summertime now. It's wintertime just left. It's like fall and spring, summer sprinkled in. How do you think it's? Why do you think it's summer?
Due to you are spinning it in circles
Yeah, in circle. I'm going to spin it in a circle.
slowly.
Slowly. And we're done. Basically, check it out. You're here, or so, like right in this area. Am I closer to the sun than anywhere else? Or further away? Imagine down here. Who's closer to the sun? Sun's over here. We're summertime. If the tilt is facing towards the sun, it's summertime for us. If the tilt is facing away from us, it's wintertime. So right now it is summertime next. And wintertime again. Now, flips around. Now how this happens is this right here is the tilt. By the way, on the internet, I'm showing a demonstration in class, so sit tight. So this is spinning. We're my sun, right? We go over this. Okay, here's my sun. So right now, facing here, this is hitting the sun's hitting us more, summertime. So as I rotate this around, now I'm literally on the opposite side of the year. Now I'm facing further away from the southern hemisphere. It's wintertime now.
Oh, that makes too much sense.
These are the various equinoxes in between. Does it make sense to you?
No, it really does make sense.
It doesn't do this and then like rotate.
We're going to be on the opposite side. But
Yeah. So like right now, it's going to be summertime for us. It's going to get ready to be wintertime for Australia.
Yep.
And then when it's summertime in Australia, it's basically December here. Which is weird because I had friends from Australia come one time. It wasn't friends, like family, and they were in school and like wintertime, like, you know, like, oh, it's so hot right now. Like, oh yeah, Australia's like a desert right now, huh? They're like, no, moron. It's summertime right now. And I'm like, oh, I got a science teacher. I should have known that. It was a few years ago. I should have had a conversation. I didn't think of it because it just speaks to my mind. I didn't see everyone has this world that I live in. So we're going to change next. Okay. So why do we have seasons? The tilt of the axis, right here, remember the tilt matters, and also the rotation. If I'm on one side of the, basically the ellipse, then it's summer, like right now it's winter. If I'm on the other side, watch your head, here comes the moon, here comes your, watch out. Summertime.
Right.
Well,
No, we're all dead.
we're all dead because they're upside down.
And the answer earlier. Wouldn't it still be going around the
It is, but check this out. So if I'm facing here, say you're in the sun, what's directly facing you? What do you directly see? This is you know, southern. It looks like Africa, you know. Southern Earth. So this means direct sunlight. Up here, it's not getting direct sunlight. You can barely even see it. That's why. If I had it like this, and I rotated it so it's perfectly like this, if I stopped it in the same place, what do you see? Both of them. It'd be the same temperature in north and south. Now, it's further away. That doesn't change. Next. So there it is there. Top one is the winter time for us, summertime for the south. Spring and autumn are basically equinoxes. It's when it's kind of the same as it rotates between the two major seasons. Summer and winter would be the bottom one. Summer for the northern, winter for the southern. Next. Next. A lot of these are just showing the exact same thing. Next. 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 Okay, phases of the moon. Next big concept or topic. The easiest way to remember this. I'm going to say the right term this time because it's recorded. This time I won't mess up, I promise. Last time I said the wrong term. Okay, there's two different words. There's actually about three or four, but let's just pay attention to a couple. Waxing. Of course. Waning. New moon. Oh. full moon, gibbous, Gibbous, and crescent. Ooh!
So,
One guy excited for crescent. Crescent moon, but what?
No, because
Insane!
just saying it like 500 times.
Oh, 500 seconds. All right, so check this out. And you can better remember this.
That's wrong.
Very good. Start with, let's just say, let's start with the, we go next one. I think, let's see where they're starting, because it doesn't really matter. Next. This is a good one. Next. Okay, right. So let's start at the top. Full moon. Light hitting it. It means the sun is hitting it, and there's nothing in the way. It's directly, basically behind us, and it's hitting there. We can see it. We'll go over that relationship in a second. As I start going, gibbous is the bigger moon. Not, it's like a full moon, but it's the bigger moon. It's not a crescent. You guys know what a crescent moon is, right? I think over what a crescent moon is. That's the easiest one to remember. So it's a crescent. Okay, everyone saw Twilight. Everyone knows what it is.
what? No, I never watched Twilight.
You saw it twice. Twice I thought, wait.
I saw it 17 times.
I saw it 17 and a half times. I tried that. But I mean, everyone knows the crescent. The opposite of a crescent, but it's bigger than half, is gibbous. Okay? That's bigger. Now, the hard part for people to understand is the waning and the waxing. When the heck do I know what that is? I did this like 5 years ago. For some reason, I came up with it like on the fly, and the kids all got it the first time and all. Okay, I'll just use that for the rest of my life. Waning is like growing a beard.
What's your liner, like a lane liner?
No, just waning things is growing a beard. What's happening from the full moon to say the first quarter? What's increasing?
The what? The lane beard?
The beard is growing. Now check this out. Once you get the full beard, and Mr. Nader right now is full beard,
You gotta start shaving it.
what do I start waxing it? And I start getting rid of it.
You should.
I should wax my face?
No, get rid of your beard.
What are you talking about? This is marvelous.
With all the different colors.
All right, here.
How long does it take to grow?
Okay, we need a thumbs up or a thumbs down. How's the beard?
Terrible.
Thumbs up or thumbs down? How's the beard? Here we go. Turn this way.
Everybody put thumbs down.
There you go. What do you think? We got, oh! That's it, Isaac. F in my class. What do you say? All right. Yeah, that's cool. All right, so you just remember. Okay, I'm gonna go through it and we kind of explain. Full moon.
Oh my God, look at you sound good with that.
What? Good with the F. All right, so full moon. So we're gonna figure out what am I increasing? Look at the next one. My beard. I'm waning. Okay, I'm waning, but then also, is it bigger than half? Does it look bigger than half? Like the light side of it? It's not a crescent, it's not quarter, it's bigger than half. There's more than half of it there, which means gibbous. So is a waning gibbous. Then I go first quarter, I'm sorry, last quarter, right here, 50-50. There's different quarters, first and last. Just remember that. Then right here, we have a waning. What do you have left? Crescent. We go to the new moon, which you actually technically can't see. So when you look at the sky, you don't see the moon. The moon is there. It's not like it just like goes to sleep and hangs out with his brother and like it's in like a different state or something. It's still there. It's just you can't see it because the light's reflecting the opposite direction, not at your eye. And we keep going and look at. Now I'm starting to get rid of some of my beard. I have full beard right here. Can't see my face. I start going. I'm waxing. There's a crescent. First quarter, I'm waxing. Gibbous. Hopefully that helps you make sense. So think of waxing and waning as hair, non-hair, and the gibbous and is the opposite of crescent. I'm in the needle going what you're going to say.
Okay, on the moon cycle, the outside, you show all the inside, all exact same picture.
Where? Oh, here?
Yeah, we're
all
the same picture.
Yeah, you showing that basically the Earth signature. The reason why, this is actually a good point, it's your perception. What does the moon look like on your perception? The moon looks different in other parts of the world at any given time. So your moon, if you go to a different like countries, looks different because of your perception of what you're seeing. Makes sense what I'm trying to say? It's like right here. If I'm here, and I'm right here, and I look this direction, I only see half the moon, hence this. Now, if I'm here, and I look straight down,
It's same.
no. I don't see anything because the light's hitting and bouncing this way. I can't see anything that's not reflected in my eye.
Well, it depends on how the Earth's revolving then, right?
Yeah, it's where you're at. It's where you're at. And by the way, the moon doesn't do this perfectly. It doesn't go like perfectly this way. It's kind of like this. Just kind of chill and kind of. That's why when we get to the next one with lunar and solar eclipses, sometimes you can see it or not see it. Last week I was told by Janet that there was a solar eclipse in like Europe or something like last week. Well, we didn't see it. It's because as it came, you saw it, you were there. It's like, hey, I saw it on the YouTubes.
You can see it anywhere.
I see it anywhere. So you Google it.
Yeah, exactly. Just Google it. You Google it.
Google it.
89 is totally flipped. You can see it.
Yeah, nice. But basically, it went across, like it kind of went across Europe like this. So it didn't hit us. The shadow went across Europe and then went away. So we didn't actually.
And the beard's growing.
Is my beard growing again?
Yeah, however, that's there's not.
Question for you. Wednesday the 1st. What moon is that? Okay, what kind of crescent?
Give it.
No. Sure. Number one, what does it look like to you? No. It is a waning crescent. Waning crescent. See how it's, oh no, it's a waxing, I'm sorry. See how it's going away? You have to keep looking. So it is a waxing crescent. So if I look at this one here, day 27, one second. It's DreamWorks. But look at it, now it doesn't go, what's going away? It's gaining the beard, it's waning. So it is a crescent waning, a waning crescent. Okay? Anytime it's like this, it's a crescent. This is a waxing or waning. This right here, kills.
It's a Hames started came from putting out new.
Hang away for the day?
No.
What are the days?
Where did they at? On the outside.
Fantastic. Okay.
I gotta see.
All right, solar eclipse. Okay, now solar eclipse and lunar eclipse does not matter which one. It's which one's being blocked. So, in the solar eclipse, which one's being blocked?
The sun.
Solar, sun blocked, solar eclipse. We'll see what that looks like in a second. Now, a lunar eclipse, which one do you think is being blocked? Lunar, moon, we are going to steal the moon. Now we're not going to steal the moon. Too big. Are we doing Despicable Me right now? Yeah. Glad I got the reference.
Yeah.
I like it because I have a bunch of minions in the room right now.
Yeah. Yeah, you're one.
You're funny.
All right, so this is what it looks like perception-wise. So here we are. I'm sorry, just kidding. We're over there.
On the moon?
We're on the moon apparently now. No, we're on the Earth. If I'm right here, if I'm literally standing right there, it is a full, total eclipse. But look how small it is on the planet. It's like this little like shadow. That's why we all don't see it. You can see parts of it in maybe a continent area, but you're not going to see all of it. But right now, when you look up, you would not see the sun. It would be completely, perfectly in line. People fly to these areas to see it. Because we know when they're going to happen because of all the angles and a bunch of people are naturally going, well, I'm going to figure this out mathematically. And they figure it all out. They know at this day, between this time, there's going to be a solar eclipse in Southern Africa. And guess what? People fly to Southern Africa and stand there and look up in the sky. They're not supposed to look directly at it, so they'll do like different things or different shadows. They'll put like a thing so you can see on the ground. It's really weird.
It's going to happen in 2002.
Good for them.
So let's say you're in space.
I'm in space now.
And you look down.
Do I have a suit on?
No.
And I can't hear you.
We have
I
walkie
can't hear you.
We have
I
walkie
can't hear you. I don't have a suit on.
You're dead.
Technically, we'd be dead.
Okay, you have two on.
Yeah, I do on now, so now I'm alive and I can hear, go ahead.
Alright, so,
Now let's do fun.
let's do, you have oxygen, we're talking to the, radio.
Radio, go ahead.
Hey, can you see a shadow on the Earth from the moon?
Yeah, where am I at?
Right over the Earth, looking down on South Africa.
So if I'm on the moon.
No.
Hey, look at that.
We're directly, not directly over it, but we're over
We're in
the
space.
moon. We're looking exactly at this.
Yes, you can see a shadow.
But, okay, that's
Yeah.
what I was wondering.
Yeah.
Is the shadow
Just like this, it looks just like this, like I'm here going, and I'm looking at it.
Let's show some shadows of that.
But if I'm over there, I wouldn't see any of it.
I see that.
All your perception of where you're at.
Wouldn't you see the dust coming off of it? With the sunlight going around it?
Not dust.
It's dust particles, yeah, it is.
Well,
That's what, isn't that what the whole entire solar system is made up of?
yeah, but if when you're seeing a light wrap around it, it's light.
It's complicated.
Light with dust and green.
Sure, we'll say dust, but yeah, say light.
I mean, you're something off of light. How's astronomy, bro?
No, I'm saying, like, I'm worried about that. So they start adding dust to this, people get confused.
Dust. Dust.
Yeah,
Dust is
lost
dust.
particles.
Dust.
Mostly dust is made of human skin, probably not that much.
And made up of comet and star.
Comet and star. I'm excited for Comet. By the way, this is what it looks like far away.
Yeah.
You need to know the moon, from your perception here, blocks out the sun. Solar eclipse.
Yeah.
Okay, here's what it looks like. Kind of comes across. These are the phases. You can see the light wrapping around it right there. Just the light right there. And also dust.
Is this got my eyes from looking at it?
Yeah, you go blind right now. There it is in the sky. Okay, lunar eclipse, we really need to write that. Think about it, this is the moon's block. So it will be on the opposite side. So, oops, go back.
Sorry. Lunar eclipse.
So it's the exact same thing real fast. The solar eclipse will just be facing on the left of the Earth in this case. It would be on the right of the Earth, and the Earth is blocking the sun.
But you have to remember.
Now I have to remember.
Full moon during lunar. New moon during lunar.
Then you have to put all the other planets in, especially like
No. Who cares about the other planets? I don't live there.
the sun.
All right, okay. So people on the internet, if you have any questions, please ask them now. If not, go ahead and take off and answer the essential question inside of the inside the box. I'm going to go ahead and stop the recording. And you guys, again, turn it into the drop-off.